Welcome to this channel. Are you having issue with friction? Stay calm. Just make sure that you watch this video from the beginning to the end. I swear to God who made me, after you watch this video and you still have issue with friction, you have to go back to your family house and beg them. And let's go. My name is General David. Yeah, if you are meeting me for the first time, I am calculator wizard. So please and please just follow me. Now, let's see. What is friction? Friction, or let me say, frictional force is what opposes the motion of an object. That is, when you walk on a surface, there will be a frictional force that opposes your motion. But you know the funny thing is that frictional force is a contact force. It works when there is contact between two surfaces. Yeah, it requires contact of two surfaces. That is how frictional force works. If there is no contact, frictional force does not work. Now let's go. Many students do have issue with calculations on frictional force, most especially when you see different questions. So I have come to package everything together into 6 stages. So you have to follow me from the first stage to the 6th stage. Then with that, you are good to go with any question regarding frictional force. Now let me go with the first stage. For this first stage, I'll be talking about a surface, which is a plane surface like this. A plane surface. If there's a surface like this, and there's an object placed on this surface, you can see that this is an horizontal surface. And if you have this surface, they put a body on the surface like this. Trust me. As this object is on this surface, the weight of this object will be directed downward. The weight of this object will be directed downward. We'll call it W. The weight of this object will be directed downward. We'll call it W. And at the same time, we have what is known as normal force. Normal force. Sometimes we say normal force, the normal force, the denotation of the normal force can be N or R. In some textbook you see it as N, and in some textbook you see it as R. Now, this normal force is always perpendicular to the surface of the body to the surface on which the objects rely. Now, when you talk about the weight is not necessarily, weight is always vertically downward. Weight is always vertically downward because the weight of an object is working with the ground. Because every object always directed towards the ground. Even if you throw something up, it should definitely make sure that it reaches the ground. And that's the weight. Now this is the normal. What is this normal? This normal force is the force of this surface on the object here. That is why it is pointed towards up. So the normal force is the force of this surface on this body, whereby the weight is the force of this body on the ground or on the surface. So you can see that they work in oppositely direction to each other. Now let's go. That's all about the normal force and the weight. Now let us now talk about the frictional force and the applied force. Let's say we are still talking about the ground here. Let's say you have the mass of the body like this, and you applied a force here. So this F here, we'll call it applied force. Applied force. Applied force means the force at which the person used on this object. Now let's say there is an applied force here. Applied force can be push or pull. can be push or pull. All these push and pull, they are forces. They are the forces that, when you push something, that means you draw it here. When you push it, you you push it, you understand? Now, when you talk about the apply force, the apply force, when let's say you apply the force towards this direction, it goes like this, then there will be frictional force that will opposite this apply force. I am not saying that frictional force opposites the applied force. Let me label this as frictional force. I am not saying that frictional force opposite the applied force. Why am I not saying this is because frictional force just opposites the motion of the body. But let's say when you apply the force like this, when you apply the force on this object here, you definitely know that the object will definitely go like this. And as the object goes like this, the frictional force will opposite it back like this. So that is the reason why we say the frictional force opposite the what? The motion of an object or the motion of a body. Now let's proceed. Now I've not started the step right yet, so please follow me. Still on the normal ground like this. Let's say the body, or let me say the mass of a body rests on the object like this. Now let's say the applied force is like this. You can see at this place the applied force walk towards this, but at this stage the applied force coming like this. If the applied force goes like this, the motion of the body will go like this. Then the frictional force will opposite like this. But here, as you apply the force like this, obviously the frictional force will go like this. So that means that we have the frictional force like this. Now, I have tried my possible best to explain what exactly or how exactly the applied force work and the frictional force work. And at the same time, I have tried to explain how the normal force work and the weight, how it works. And don't forget, constantly we have the weight to be equal to mass times acceleration due to gravity. That's why they call it mg. And you should know that this g, which is acceleration due to gravity, is always 9.8 meter per watt per second square. It has a constant value. This acceleration due to gravity, it has a constant value, which is 9.8 meter per second square. So let us proceed. Now, before we go to the steps, I still want you to understand that the axis matters as well. You all should know, when you talk about the axis, this is positive y-axis, this is negative y-axis, this is positive x-axis, and this is negative x-axis. So in short, we are going to be using all these axes to explain or to resolve all these frictional forces. So now, we have four axes like this. So with that, we are going to be using this. So that means if there is any force that is working towards this positive direction of x, we are going to have it to be positive value. If there's any force working towards this negative direction, we are going to take it to be negative x, like the negative value. And if we have any force going towards the positive y, we are going to have it to the positive value. And if we have a force going towards a negative y like this, we are going to have it to be negative value. Now that one aside. At the same time, when you are talking about frictional force, you are still going to understand the fact that the formula for frictional force, it says that frictional force is equal to coefficient of the frictional force multiplied by the normal force. In some textbooks, they have it like this, or you have it as Fr is equal to the coefficient of the frictional force multiplied by what? R. I told you that in some textbooks, they represent normal force as N, or they use R. So that means anyhow you want it. It is either you use N or what? Or R. But from here, I'll be constantly using N. I will not use R. So that means whenever you are saying N, it represents what? Normal force. And when you talk about this axis, the summation of the forces of the y-axis is always equal to 0 here. And the summation of the x-axis is also equal to 0. Please, you have to take note of all this before we proceed. If you truly get all this, then I am telling you, with the first thing I explain here, when if you can get this at the same time, you can get this correctly, you are good to go. I will advise you, if you can pause this video and go back to all those two, or let me say, the two illustrations I just made, then before you proceed. If you can rewind this video back and get the explanation of all this aspect well before we proceed. Now let's go to all the stages now. Stage one. Now, when you talk about the stage one of this friction, I'm going to be drawing two things here. Now check this. Check this. Let's say you have, I'm still on the horizontal. Let's say you have the mass of the body like this. If you have the mass of the body like this, the weight of the body directed downward. As I told you, then let's see the mass, the normal force directed upward. I told you the normal force is the effect of this on the object. It will always directed like this. Now this one as well, the mass directed downward, the weight directed downward, and the normal force directed upward. And as you all know, that this condition, it relies on, the reason why I'm using the 2 here is because this thing relies on the direction of the applied force. Let's go. The direction of the applied force matter here. Let's say they apply a force towards this direction. If the applied force is like this, once the applied force is going towards this direction, then the frictional force will come towards this direction. Once the applied force comes like this, the frictional force will come towards this direction. Now, let's say that the applied force comes towards this direction, then it's obvious that the frictional force will come towards this direction. That is 2. So I want to look at the two cases now. This means that it's going towards this direction. This means that the applied force is going towards this direction. So now, let's go. For the first case here, for this part A here, for this first A, let me label this as A and label this as B. So for this first one, I want to resolve this into two directions, like the horizontal axis and the vertical axis. Don't forget that this is positive x, this is negative x. This is positive y, this is negative y. So let's go. For this, let me firstly talk about the horizontal. Now for the horizontal is x-axis. So, and as you all know, the summation of the horizontal axis here will be 0. And if the summation of the horizontal is 0, and that means that we are going to have the summation of the horizontal. Summation means you are adding them up. Now, what are the horizontal forces here? Horizontal forces is the friction and the applied force. So, but don't forget that the applied force here is working towards the positive. So I will be having what? Positive F plus into the bracket of the frictional force is working towards negative. So I'll be having minus FR. Then everything is equal to what? 0. Now in this case, I want you to know the power of equals to. The power of equals to is like, if you can say A is equal to B equals to C. Now if you have A to be equals to B equals to C, it means that I can say that A is equals to A. I can say that A is equals to C. I can say that B is equals to C. That means that that's what they call equals to. With this short explanation I made here, I can say that summation of f of x is equals to 0. Summation of f of x is equals to this. And this is equals to this. So it's the same thing. Now, but I have interest in this one and the 0 here. So let me bring the 2 out. So I can say that f plus into brackets minus fr is equals to what? 0. So obviously I can say that f minus fr, plus times minus will be minus, equals to what? 0. So f will now be equals to, if I should take minus f to this side, it will become plus fr. Minus fr to this side will become plus fr. And that is why whenever you are solving like this, they always say that f is equals to fr. Can we all together? This is just the condition. But mind you, under the frictional force, we have what is known as static friction and kinetic friction. Are we all together? Now, if you apply a force, let me say that the frictional force that is holding the mass of a body is like 50 Newton. You know that obviously, if you want to apply a force on this 50 Newton, so that it's going to change from static frictional force to kinetic frictional force. Static frictional force means the force you applied, the frictional force in what? When the object is at rest. But kinetic frictional force means the force, the frictional force when the object is in what? Is in motion. So that means I need minimum of 50 Newton on this object because the frictional force is 50 Newton. So I need minimum of 50 Newton to move this object so that this object can be what? Can move. So that's it. That's just the explanation between the static and the friction and the kinetic. But I'm not going to that aspect. I've explained that before. You can watch more of our video on the channel. Now let me go. I've been able to resolve the horizontal component of this. The same thing will happen to the vertical component. Let's go for the vertical component. Vertical is summation y. So I can have the summation y to be equals to what? To be equals to 0. So let's say the summation y is equals to 0 here. So if the summation y is equals to 0, so I can now say that, okay, summation y, so summation fy rather, will now be equals to, oh yeah, what are the forces at the vertical? You can see I'm still explaining A here. I've not moved to B. So for the forces vertical here, we have the n, but n is working towards the positive y. So I have positive n, then plus, into brackets, the weight is working towards negative. So I have it to be minus w. Since the summation of the forces is equal to 0, so I have this to be equal to 0. Then with the explanation I explained here that A can be equal to B, while B can also be equal to C. That is, if this happen, according to what we have here, then can take any one out of this equation. So I'm bringing this and this one. So I have n, then plus into bracket minus w to be equal to what? 0. Then obviously, when we open this bracket, I have n minus w to be equal to 0. Then n can be equal to what? W. So that means with this is illustration here, I have the normal force to be equal to weight. I have the force to be equal to what? Frictional force. Though you have to get this explanation right because in some cases, it may not be like this. It depends on the parameter given to you. So you get me now. So you have to follow the trend of the words of the question because in physics, you have to interpret very well. Now let's go. With this second case now, let me explain the part B here. For the part B, when you see the frictional force is the one going towards the positive, then the applied force is going towards the negative. This one is going towards the positive, this one is going towards the negative y, as you can see. So let us go. If you can see now, let's go. Let me firstly resolve the horizontal components. Now to resolve the horizontal component, we know that the summation of the horizontal component is 0. And with this, I have the summation of the horizontal to be equal to the one that works towards the positive is what? Is the FR. So plus the one towards the negative is the what? Is the applied force. Everything equals what? 0. Which what I've done in the first illustration. Then bringing this out, I have the FR minus, plus into brackets minus F to be equal to 0. Then open this bracket, I have FR minus F to be equal to 0. Then FR will be equal to, when you take minus FR to the other side, it becomes what? F. So this thing, as you can see, is the same thing with the first illustration. The reason why I brought this second one is because the summation of forces, when they say summation of forces, either, when they say summation of the forces, either horizontal component or what? Or vertical component. You know that force is mass times acceleration. Force is mass times acceleration. So the summation of the forces is equal to what? MA. Is equal to MA. So in some situation, let me use this one for instance. In some situation, they can ask you to find acceleration. So I will not say this is equal to 0 now. I'll say summation of the f of x is equal to this side. So if I say that summation of the f of x, okay, let me take that as a new chapter. So I'm taking B and C here. That is this one and this one first. And now let's go to the vertical component of this one now. The vertical component of this one, I have summation of y, so which also equals to what? 0. So summation of the y is equal to 0. So obviously, we have, coming to this, what is the summation of the y here? So I have the summation of the y, that is the vertical component here, will be equal to the n here is the one going towards what? The positive. Going towards the positive. So I have the n, then plus the weight is going towards the negative. So I have it to be what? Minus w. Everything equals 0. So in this case, I am still taking these two sides now. So I'll be having this be n, the minus or yeah, plus into bracket minus w, everything equals to what? 0. Now, as we've been doing that before, you can say that I can what? I can open this bracket. So by the time I open this bracket, I will have it to be n, then minus w to become 0. So n will be equal to, if you take minus w to this side, it will become plus w. You can see that n is equal to w here. The same thing with this. You can see that it's the same thing. So either you take it to be this or this, you are going to have the same thing. Now, I want to take these two sides. Now, from this just case 1 that we just concluded, you can rewind it to the back. I told you that when you have summation of f of x to be equal to f, then plus into brackets minus fr to be equal to what? To be equal to 0. Now, yes, from this case. Now, if I am not taking these two sides, I'll just do two illustrations here, then I'll move to the second case. If you don't want to take these two sides, you want to take this one and this one. You understand? You want to take this side and this side. As I told you that A can be equal to B, which can be equal to C. So I want to take A and B, like these two sides. So I can say that summation f of x is equal to f, you understand? Then plus into bracket minus fr. In this case, summation fx, that is summation of force, is equal to ma. So if summation of force is ma, I can substitute this to be ma, which is equal to f minus, when by the time you open this bracket, plus times minus what? Minus. So I can have it like this. Or better still, I have it to be summation f of x is equal to f minus what? Minus fr. So you can have it like this. That's for the first case here. Now for the second case here, I can have the summation of fy to be equal to what? To be equal to n. Then you have it to be plus in the bracket minus w, which is equal to 0. So if I'm not taking these two sides, if I'm taking these two sides, I'll be having summation fy to be equal to n. Then you have it to be, if this minus open this bracket, it will be what? It will be minus w. So I can have summation of fy to be equal to n minus what? Minus w as well in this case. So let us go to the next case. Don't forget, I'm going to 6 cases. So the next one will be the next case now. Now this stage 2. This stage 2 is when we are still on horizontal plane. Like you have this plane like this. Let's say you have this plane like this. The mass of the body rests on the plane like this. And at the same time, you have a rope. Let's say you have a box. You now tie it with a rope. You are now drawing it. You are drawing that rope with a force. Now, if you are drawing this with a force, the applied force will be going like this. This is an applied force. But don't forget that this thing is on the what? Is on the horizontal surface. It is on the horizontal surface, but you are dragging this mass. You are dragging it like this. You understand? It's going like this. Since it's going like this, then don't forget that as you are applying force like this, the motion of this body will be going like this. If the motion of this body is going like this, we'll be having frictional force. It will opposite the motion of this body. Because you are dragging this object like this, the frictional force will opposite the motion. As the motion is going like this, the frictional force will go like this at the same time. Don't forget that the weight of these objects will go downward, as I explained in the first stage. At the same time, we have the normal force. The normal force will go up like this, as I explained in the first case. The normal force will go up. Now, if the normal force go up at the same time, let us now see. This one is a bit different from the other one. The reason why is because the other one that we did, the applied force goes horizontally. But this one, the applied force is not going horizontally and is not going vertically. So we have to resolve this. But the rope that you apply here, the rope that you are using to drag this object, it will be used, like it will occur at a particular angle. So let's put the angle here. This should be angle. So there's a way. If I should shift, like if I should reduce the height of this force to this place now, that means the angle will also be reduced. You understand? So that means that the angle at which you drag this object matters. That's why we are putting the theta here. But the applied force that you are using is going like this. Now you have to, in physics, you have to resolve this force into vertical and horizontal. Into vertical and horizontal. The shortcut I normally tell my students is that, see, anywhere you have the theta, just put it as cos. So that means we want to resolve this force into vertical and horizontal. This is the side at which you have your theta. So put this as F cos theta. And this is the other side. Put it as F sin theta. So the side at which you have your theta, put it as F cos theta, and the other side put it as what? F sin theta. This is a shortcut. But if you have interest to know the correct, like how to resolve this normally, if you want to resolve this thing normally, let me quickly do that for you. If you want to resolve this normally, now check this now. Anyway, let's go. If I want to resolve this normally, like this is a shortcut though, but the shortcut will be used by you, because if you want to pass through this one, it will, you may find it difficult. But let's go. I just want to explain, in case of those in physics department, that you may want to what? You may want to get the explanation correctly. I'll draw the this thing again. The box is here. Now, if the box is here, I put something like this, and the theta is here. The theta is here. You have the force like this. This is the force. The theta is here. And we are together. Now, when you check this forms an angularity like this. The box is there. This form an angularity like this now. You can see, this is what I draw. This thing. This is what I draw out. Now, you will all believe with me that if the theta is here, the force is going like this. If the force is going like this, then the vertical component of this force will be like this. And the horizontal component of this force will be like this, because, both horizontal and the vertical will meet at the particular point at which this force F is going towards 2. And as you all know, that this force F is going towards this point, then the horizontal will be like this. The horizontal will go like this to meet this, then the vertical will go like this to meet this. So if we know this value here, if you know the value here, it's going to represent the vertical of this side. If you know the value here, it's going to be the same thing with the what? With the horizontal here. So as you can see, the horizontal arrow is going like this. Can you see the horizontal? This one, the vertical is going towards up, the vertical is going towards up. So let me quickly resolve this for you. And as we all know, in physics or in mathematics, anywhere theta face, this is the theta, anywhere it face, it is called opposite. Anywhere theta face is called opposite. And this is angularity here. And anywhere angularity face is called hypotenuse. Now, the third one will now be adjacent. Now, I've been able to list this. Again, anywhere theta face is opposite, anywhere angularity face is hypotenuse, then anywhere, the third one, you just have it to be what? Hypotenuse. We have this to be opposite, anywhere theta face is opposite, then anywhere angularity face is hypotenuse. And the third one, just take it as what? Adjacent. Now, I want to get the same thing here. Now, you know that we have what you know as SOHCAHTOA. SOHCAHTOA. And what is SOHCAHTOA? SOHCAHTOA, for this one, it is sin theta is equals to opposite over hypotenuse. Sin theta is equals to opposite over hypotenuse. That's what we have here. And this one, we have it to be cos theta to be equals to adjacent over hypotenuse. That's what we have here. And this one is tan theta is equals to opposite over what? Over adjacent. And as you all know, what am I looking for here? I am looking for the opposite. I am looking for the what? Opposite the vertical component, which is this one. And I am looking for the what? For the adjacent, which is the what? Which is the horizontal component. So you get me now? So which is the horizontal component? So now, let's go. Let me look for the opposite here. The opposite here I can get it from, let me use, we are given hypotenuse. We are given hypotenuse, and hypotenuse is F. So out of this, which one contain opposite and hypotenuse? That is sine. So I'll just say that sine theta is equals to, we don't know the value of opposite, and that's what we are looking for. Opposite over, we are given the value of hypotenuse, which is F. Then everybody make opposite the survey formula. Opposite will now be equals to F sine theta. So can you see? So opposite is F sine theta. Now look up. Where's our opposite? These are opposite. So that means this opposite is F sine theta. And the F sine theta here is the vertical. And that's why the vertical here is F sine theta. So let's go and get the horizontal. How do we get horizontal? I need where we have adjacent and we have hypotenuse. Don't take this place. Don't take hypotenuse here. This hypotenuse is for this side. You understand? So now, I need what contain adjacent and hypotenuse. And that is cos. So do the same thing. Cos theta is equals to, I am looking for adjacent. So let me put as adjacent over, and we are given hypotenuse to be what? To be F. Now making adjacent the survey formula. Adjacent is going to be equals to F cos theta. And as you all know, I have the adjacent to be F cos theta. So that means that what is here is F cos theta. And mind you, under the law of triangle or angle like this, whatever is here is the same thing with what is there. So that means that if this side is F cos theta, what will be here will also be F cos theta. So that means that the horizontal component of this force is F cos theta. And that's why we have F cos theta here, and the vertical we have F sin theta here. So the same thing with this one now. This one is F sin theta. This will also be F sin theta according to the law of angle. Now let's come back to this. And let us now resolve this. Since we've gotten, or we've listed everything on this structure, then let's go with the summation of the words of the forces. Now let me go with the horizontal. Horizontal is, don't forget that we have the positive x here, we have the negative x here. We have the positive y here, we have the negative y here. You understand? So let's go. Now, as you all know, if I want to, summation of the horizontal, summation fx will be equal to 0. Now, if the summation fx is equal to 0 for the horizontal, then you have to check. I will now have the summation fx to be equal to, you now ask yourself, what are the forces that go to horizontal? We have this one goes to horizontal. The Fi here, which is the frictional force, also pass through horizontal. But you can see that we have F cos theta here, it moves towards the positive x. So that's why I have plus F cos theta plus the other horizontal here is Fr, and it's going towards the negative. So I have it to be into brackets minus Fr. Everything is equal to what? 0. Now if this one is equal to 0, I will now have summation Fx, is of 2 here. Like I did for the previous one, I can say summation Fx, like, let me do it again. As I said that A can be equal to B, in which B can also be equal to C, according to this. That is, I can say that summation Fx is equal to F cos theta, then minus Fr, according to this. Or, that is, I'm using this and this. You can say that this is equal to this. Or you should say that this one is equal to this as well. Which means that F cos theta minus Fr can also be equal to what? 0. All these words are correct. So it depends on what you are looking for when you are solving this. Now, if I'm proceeding with this one now, if I say F cos theta minus Fr is equal to 0, so I can say that F cos theta is equal to, if you take this one to this side, it becomes what? Fr. So in this case, I can say that Fr is equal to F cos theta, or F cos theta is equal to what? Fr. That's for the horizontal. Now let's go for the vertical, everybody. Summation Fy is equal to 0 according to the vertical analysis as well. Now, if you are going for the vertical analysis of this one, you should all believe with me that the vertical, this time around, unlike the other one that we solve here, that we only have 2 forces for the horizontal. This one we have 3 forces. We have N, which is the normal force. We have F sin theta, then we have weight. There are 3. So you still have to do the same thing. So I have summation Fy to be equal to, now, the N that we have here and the F sin theta, they are moving towards the positive y. So they have plus, like I have it to be plus n, then I have plus f sine theta, plus n, and plus f sine theta, because both are moving towards the positive y. Then plus the weight is moving towards what? Negative. So I have it to be plus minus w. Everything equals what? 0. That is, I have the 2 working towards the positive, then I have the weight working towards what? Negative. Now in this case, you have two choices there. Like you can say the same thing. We can say that A is equals to B, then B is equals to what? C. I can decide to say that this side is equals to the one in the middle, or the one in the middle is equals to the one which is 0. So I can say that summation Fy is equals to the one in the middle, which is n plus f sine theta minus w. You can see, you can have it like this. Or you can say the one at the middle is equals to this, which is n plus f sine theta minus w is equals to 0. In which, by the time I have it, I can take minus w to the other side here. So I will have it to be n plus f sine theta to be equals to what? W. So this formula holds. And don't forget, please take notes. W is weight is always mg. W is weight is always what? Mg. And at the same time, if W is equals to mg, don't still forget that we have a general formula for friction. The general formula for friction, which says that the frictional force is equals to coefficient of the friction multiplied by the normal force. So please, you have to take notes of all these formula as we are going. Now, this is the end of the stage 2. So I will be moving to the stage 3. Please, hope you are getting it. If you are getting it, just encourage me in the comment section. Just drop something in the comment section. Now, this stage 3. You have to follow me. Hope you are getting it. This stage 3 is somehow, sometimes they always ask questions like this. Let me give you the illustration. The illustration is that you have a wall. Wall. If you hear Yoruba very well, because I'm in Yoruba, you understand. Yoruba, the word means arrogiri. Now, if you have the wall, let's say there is a wall. This is a wall. You now apply a force. You apply a force like this. You apply a force to hold a body. To hold a body. You can see. This example is one of the reasons why you cannot say that frictional force opposes applied force. No. Frictional force opposes the motion of the body. Please take note. It's not the applied force. The force here, you use it to hold this body. Now, as you use this to hold this body here, you believe with me that this body, this is a wall. This is a wall. Wall. This is a wall. Now, imagine you remove your hand. If you remove your hand, you should know that the weight of this body will be directed downward. The weight of this body will be directed downward if you remove your hand from this thing. So, weight of this body is vertically downward. It will not be towards the surface again. It will be downward. That's the weight. That's how weight operates. It works vertically downward. So, for the fact that you are using your force, you apply a force to hold the body on this wall. No, the weight here will work directly downward. Now, if it works directly downward, you believe with me that, I have the applied force here, I have the weight here. I want to resolve it. I told you that the normal force will be here. Why is normal force here? When we started, I said that normal force that you have here, let me bring it. The normal force that we have here, is the effect of the surface here on the object. The effect of the surface on the object, that's the normal force. So the same thing. This is surface. This is surface. This is the wall. This is surface of the wall. And since this is the surface of the wall, the effect of this wall on this object, so that is what they call normal force. So that's why the normal force is coming like this. So it is not coming like you can bring it to yourself. I can draw it like this thing. This thing I can do it like this. I can do it like this. Since the wall is like this, this is the object. I can say that the force applied is like this. Now, if the force applied like this, then the normal force will be like this. So it's the same thing. But for me to have 4 cardinal points, like 4 axes, that's why I'm bringing it from this angle. So the normal force here is the effect of this object, of this surface on this object. You get me now? So that is it. But weight, what? It works vertically what? Downward. That's weight. At the same time, if your weight is going like this, if the weight is going like this, if you remove your hand, the weight of the object will be going like this. And at the same time, if you remove your hand, the body will be moving like this. And if the body is moving like this, the frictional force will oppose the motion of the what of the body. That is why we have the structure like this. Again, let me repeat myself. You use your force to hold the body on the wall. Then don't forget that the normal force is the effect of this surface on this mass. At the same time, the weight of this body, it will what? It will point what? Downward, because it will move towards what? Downward. At the same time, as it's moving downward, the frictional force what? Will oppose it like this. So that's how we have it. So let's go with our analysis. We have this to be positive x, we have this to be negative x. Then we have this to be positive y, we have this to be what? Negative y. So let's go. Let's go with the summation. What's the summation fx? Summation fx is what? Is 0. If the summation fx is 0, then what are the x axes here? This one, but like, you have to get this right. Because this force, this applied force, is going like this. So it's going towards x. It's going towards positive x. So summation fx will be equal to, and we have positive f. That I place f here does not mean because the f here is pointing towards this place. So it's going towards positive x. It is this end that is going towards what? Negative. So this one is going towards this. This one is coming towards this. So f is going towards this direction of what? Of positive. So I have it to be plus f. Then plus into bracket. N is going towards negative. So I have it to be minus n. Everything equals what? 0. So in this case, I have two choices. Like as you all know, I can say that summation fx is equal to f minus n. Or I've used this and this. Or I say this one and this, which is f minus n is equal to 0. If I say f minus n is equal to 0, I can say that f is equal to what? N. Or n is equal to what? F. So that is all we know about what? About this case. You can see that sometimes it changes. It just depends on the structure of the words of the question. This is the what? The horizontal component of this word, of this explanation or of this question. Now let's go towards the words, the vertical. If you are talking about the vertical, I say that summation fy is equal to 0. And don't forget that I told that the summation of the forces is ma. Summation f is what? Is ma. Summation of the forces is ma. Please take note. I said that before. Now summation fy is also equal to 0. So assuming I need this, I can put summation fy to be 0, or summation fx to be to be 0, or to be what? Ma. It depends on what I need. So summation fy is 0. Summation fy are those ones that belong to what? Vertical. Or the vertical axis. And as you all know, the fi here, which is the frictional force, it is found at the what? At the positive y. And the weight is found at the what? At the negative y. So I will say the summation fy is equal to, this one is the positive, which is fr, then plus into bracket, the weight is what? Is minus, which is minus w. Everything equals what? 0. Then I can have the summation fy to be equal to fr minus w, or I say, is that I use this and this, or I use this and this, which is fr minus w to be equal to what? 0. And finally, I have fr to be equal to what? W. So, but see, with this explanation, don't still forget that the formula for the frictional force still said that coefficient of the friction multiplied by what? Normal. This is it. So this case is used when you have an object pinned on the wall. You have an object pinned on the wall. This is the third case. Now the fourth case, we are going to venture into inclined plane. Now frictional force that happen on an inclined plane. Let us go with that. That is the stage 4. Follow me, please. Now, let's go to inclined plane. Let's go to inclined plane. That's stage 4. Stage 4. Inclined plane. Inclined plane is like this. You have to get it well. Let me explain what inclined plane is. This is a ground. This is a ground. They will now put an inclined plane on the ground. This is how the inclined plane structure is. Once they place an inclined plane like this on the ground, an object is placed like this on the inclined plane. An object is placed like this on the inclined plane. Once the object is placed like this on the inclined plane, my dear sister, my dear brother, then this ground is not the surface again. This is our surface. This is the surface. Because this is the surface on which this object rests. Unlike the first one, the second case that we did, all these ones are horizontal surface. You can see the way the object is placed. But this one now, the object is placed like this. First thing I want you to know here is that the normal force of this object will be like this. The normal force. Why is it that the normal force is not like this one? The reason is because, don't forget, when we started, I said the normal force is the force of this surface on the object. And when you check the structure of this surface, the structure of this surface is like this. That's why the normal force is going like this. This one, the structure of the surface is like this. That's why the normal force is like this. So, assuming the object is like this, then the normal force will be like this. But the object is like this, like the surface is like this. So, the object and the normal force is always perpendicular. It's always perpendicular like this, forming angle 90 with the surface. The normal force always form angle 90 with the surface. The same thing with this as well. This is the surface. And the normal force here form angle 90. Can you see? It form angle 90 with the surface. The same thing with this. The normal force will form angle 90 with the what? With the surface. That is the simple analysis about what? About the normal force. Now, when you have it. The next thing, after we've gotten the normal force, the next thing you are going to know is the weights. The weights. Irrespective of the plane you use, irrespective of the structure, the weight is always vertically what? Downward. The weight is always vertically downward. Let me remind you of something. When I did the first one, I said, when I did the first one like this, I said that the weight is going like this because it's vertically downward. That's the first case. When we talk about the second case, the weight is still vertically downward because of the structure of the words of the object. It's still going vertically downward. Despite the fact that this is still pinned to this wall, the weight is still vertically downward. The weight of this, or the weight of an object, of everybody, is always vertically downward. Now, let's go. Since it is vertically downward, we now have to resolve. You know what we are going to do? We have to resolve these weights. But let me go to another explanation here. Now, since you've gotten this, I hope you've gotten this explanation. The angle of inclination will be here. So this theta is called angle of inclination. The angle of inclination. The angle of inclination. So for this case, this is the stage 4. This stage 4, you can see that this place, we have it to be height of the plane. This is the height of the plane. Now, the height of the plane is this place. This place will serve as the height of the plane. This is the theta, that is the angle of of inclination. That is the angle at which the angle that determines the height of the of the object placed on on the inclined plane. The angle of inclination. The angle of inclination, that is the angle of the inclined plane. Now let's go. Since we've gotten the normal force and the weight, let me proceed. Don't forget, we have the ground like this. Since we have the ground, okay, let me take another book. Let's say we have the ground like this. Since we have the ground like this, the ground like this. Don't mind my structure. Then we have the inclined plane like this. We have the theta here. Then this is the height. Don't forget, as I label it. then the object is like this. We have two stages on this inclined plane before I proceed. Like I have two parts. So I will use this stage 4 to explain one part and use stage 5 to explain another part. So let me use stage 4 to explain one part. The part I want to use here is that this stage, it occurs when an object move downward, move downward. That is freely. It's moved downward freely. This thing. When an object moves downward freely. Now, what we mean is that, what I mean by when an object moves downward freely, it means that, this is an inclined plane. Sometimes they will say a frictionless inclined plane. A frictionless inclined plane, when you place an object like this, you place it on this inclined plane, and it is frictionless, the object will be moving down by itself. It will move down. So it will be coming down by itself. Now, if the object moves down by itself, that means that there is no applied force on it. There is no applied force. There is just internal force that is taking it down. So there is no applied force. So I will use a case whereby there's an applied force. I use a case whereby there's no applied force. So if there's no applied force like this, like it's moved frictionless downward, don't forget the first thing is that the normal force. The normal force acts like this, like to the top. And at the same time, it moves downward, Abby. So it moves downward as the motion of this object moving downward. As the motion of the object move downward, you can see the frictional force was opposite the motion of the words of this object. It moves in opposite. Now, when you check this, let's say we now have the weight like this. This is the weight. This is the weight. The weight. I told you that the weight moves downward like this. Now, if the weight moves downward like this, we now resolve this weight into this component. So, if you resolve weight into two components like this, you are going to observe that the reason why we are doing this is because it's going to align with this and it's going to align with this one. You can see. So we are going to resolve this weight that we have into this component. And as I did in the second stage of this place, when we resolve this force into two components, I told you that the one that is at the side of the words of the theta should take cos, and the other one should take what? Sine. The same thing I will do here. If we are resolving this weight, the one out of these two that is at the side of this theta should take cos. So that means this one will be W cos theta. And this other side will be W sine what? Sine theta. Now, if this one is W cos theta and this one is W sine theta, then we can now say that, should I still prove this again? Let me prove this. The reason why this is W cos theta and this one is W sine theta. But the best shortcut you can use is that, just say that the one that is at the side of the theta should take cos, and whereby the one that is at the other side should take what? Sine. So let me prove it. I want to bring this side. I want to bring it here. So let's say you have something like this. You have the inclined plane. You have the object like this. When you have the object, you have the theta here. So if you have the theta here, let's say, we have the weight like this. This is the weight. This weight that we have here. This is the weight. If you have the weight like this, the force that moves down this plane, let's say we have it like this. This is a force that moves down this plane, and that's the same thing with these words I have here. But because of this arrow to show, that's why I did not place it on this line. So I place it here so that the arrow will show. But there's no force here. Everything happens at the surface. You understand? Now, what's now happening is that when I have this force that moves down the plane, I have the weight like this, I also have, this is the two resolution. You understand what I'm saying? The two resolution, you resolve this weight, we have it like this. Now let's resolve it into two. If you want to resolve this weight into two, you are going to have you are going to have the component like this, because the weight is coming like this. You have the component like this, and you're going to have another component like this. You can have it like this, or something like that. Or better still, don't bring this up. Let's do it like this. Let's have it one. Since this is weight, the weight is here. Then this is another word. This is the height like this. That is the one that comes towards the vertical like this. But you can draw another line like this. But instead of us using this, let's use a side. So if the theta is here, let me tell you this: the theta that is here is the same thing with the theta that is here. Any theta that is here is the same thing with the theta that is here. Should I prove it to you? You should know that this this side here is like 90 degrees. So if this side is, let's say that this place is 30 degrees. So if this place is 30 degrees, and you will all believe with me that if this place is 30 degrees, this place is 90 degrees like this. And angle on a straight line is what? Like let me say triangle. Triangle is summation of the triangle is 180. If this place is 30 degrees, this place will be 90. 30 plus 90, that's 120. This is a triangle here, this is a triangle here, this is a triangle. If these two sides take 120, this side should take 60, because it will remain 60 for this side to be 180. So 30 plus 90 plus 60 will give us 180. Now, and when you check this structure and this structure here, this structure and this structure, they make 90 degrees. So because they make 90 degrees, you can see that since this one is 60, when you now say 90 minus 60, this plate will now be what? 30 degrees. So which makes this side to be 90. So you can see that the 30 degree here is the same thing that is here. So I can see that the theta that is here is the same thing with the theta that is what? That is here. So this is the theta. Now if this is theta, anything that opposite the theta is called opposite. And this side is also 90 degrees. So anything that opposite the angle 90 is what? Is hypotenuse. And this hypotenuse is what we know as our what? Weight. That's the line of the weight we draw. So we have this line of the weight. So this hypotenuse is weight. And this side is what? Is opposite, because it's opposite the angle that we have here. And the third side will now be what? Adjacent. So the third side will be adjacent. Now if the third side is adjacent, according to the SOHCAHTOA, sin theta will be opposite over what? Over hypotenuse. And let me look for this opposite here. So opposite will be equal to sin theta multiplied by what? Multiplied by, or let me say better still, sin theta is equal to opposite over, and our hypotenuse is what? Is the weight. So because multiply, opposite will now be W sin what? Sin theta. So this opposite here is W sin theta. And that is why what we have here, which is W sin theta, is the same thing with what we have here. Because this line here is the same thing with the line here. So the force that moves down the plane is the same thing with this. So if this one is W sin theta, this side will also be W sin theta. And that is why what is here is W sin theta. And better still, let us solve this W cos theta. You can see that let's solve for this adjacent here. This adjacent, we can see the one that contains adjacent and hypotenuse to be cos. So cos theta is equal to adjacent over hypotenuse. So cos theta is equal to adjacent over the hypotenuse is W, which is weight. So making adjacent is already a formula. Adjacent is going to be W cos theta. So this adjacent here is W cos what? Cos theta. So adjacent here is W cos theta. So if the adjacent here is W cos theta, that means that the vertical components of this side is W cos theta. And that is why we have this side to be W cos theta and this side to be W sin theta. So if you don't want to pass through this issue, like if you don't want to pass through this explanation, just know that any side that is at the side of this theta here, take cos, and the other side take what? Take sine. Let me now resolve this. So since we've resolved this weight into the two components, this weight will not be part of the resolution again. So therefore, I'll now take this to be positive side of x. I'll take this to be negative side of x. I'll take this to be positive y of y, and I'll take this to be negative y. You understand? Just to divide this into two components. Well, now let us sum this together. Summation of the forces towards the x is 0. So if you add this, you now add this to be summation of the f of x will now be equals to, now since this one is going towards the positive x, so we have this to be We have it to be what? We have it to be Fr here, positive. Now, we have the Fr here, then this one take the minus. So which means we have plus into brackets minus W sine what? Sine theta. Everything equals 0. So you have two stages. You can say this one is equals to this side, or this side is equals to this side. So is that you say summation Fx is equals to Fr, then plus times minus will be what? Minus. That's minus W sine what? Sine theta. Or you take this side to be equals to this side, which means we have Fr minus W sine theta is equals to 0. So we have Fr minus W sine theta to be 0. So Fr will be equals to W sine theta. If you take minus W sine theta to this side, so we have Fr to be equals to W sine theta. So let us now go into the summation Fy. Summation Fy for the vertical like this is equals to 0 as well. Therefore, I can have the summation Fy to be equals to, we have n towards the positive, then plus, we have W cos theta towards the negative, which is minus W cos theta. Everything equals what? 0. So you have two choice. You can say that summation Fy is equals to n. This one will multiply this to be minus W cos theta. Or we say we have this side and this side like equals to, we now have this to be n minus W cos theta to be equals to what? 0. With this case, we can say that n, if I say n, we now because take minus W cos theta to this side. So it's going to be equals to W cos theta. Now, check this very well. At this case, I have Fr to be W sin theta. At this case, I have n to be equals to W cos theta. Don't forget the original formula for the frictional force. We have the frictional force to be equals to coefficient of the frictional force multiplied by n. You'll be shocked because making coefficient of the frictional force to be the subject formula. Coefficient of the frictional force can be equals to Fr over what? Over n. This formula I want to give you only works in this aspect. That is, whenever an object moves downwards, down the plane, like move down the plane like this, it moves freely down the plane because there will not be applied force. You will only have the what? The internal force and the what? The force down the plane will be W cos what? Cos theta. Now when you have this, we now have the Fr. What is the Fr here? Fr will be W sin theta according to this formula we have here. Over, we have n here to be W what? W cos theta. So that means that the coefficient of the frictional force is equal to W sin theta over then W cos what? Cos theta. In short, we have W cancel W. So the coefficient of the frictional force is equal to sin theta over what? Over cos theta. And in trigonometry, sin theta over cos theta is tan theta. So that means that the coefficient of the frictional force here is equal to tan theta because sin theta over cos theta is what? Is tan theta. So this is another formula. So let us proceed to the fifth stage of this frictional force. Now this fifth stage, which is stage 5. Stage 5. We are still on inclined plane, but this inclined plane is the sense. I've used the other one to explain deeply about the inclined plane. So you can have this something like this. This is the height. Don't forget the height. There's a theta here. This height is opposite. Don't forget it's opposite. This is an angle 90. This is an hypotenuse. So this place is adjacent. So in some cases, you may want to find hypotenuse, you may want to find opposite. Don't forget. And you'll be given hypotenuse. Yeah, there's a case like that whereby, the question says that an object like a body of mass, look at this now, a body of mass 5 kg, and they say that it covers 7 meters on an inclined plane. Now, it covers 7 meters on an inclined plane. It now asks us to find the potential energy at the end of the plane. We are asked to find the potential energy. Now, if you are asked to find the potential energy of this side now, they ask you to find the potential energy. Some people will say, okay, now potential energy is equal to mgh. Some people will now say, okay, since the mass is 5, and we have the acceleration to gravity to be 9.8 multiplied by, some people will now multiply with this 7. You are wrong. Because this 7 is the distance on the plane, not the height. So in short, If you now want to find this height, you now use that, okay, the theta here, let's say maybe the theta is 30 degree. If the theta is 30 degree, what you now say is that, okay, you have this side to be opposite, this side is hypotenuse because the angle 90 is here. So you now go and find this opposite. I know that the only thing that deals with opposite and the hypotenuse, opposite and hypotenuse, that's sine. Or sine theta is equal to opposite over hypotenuse. So opposite will be equal to hypotenuse sine what? Sine theta. And what's the hypotenuse here? That's 7 meter. So we have 7, which is the hypotenuse, multiplied by what? Sine 30. And when you check this, when you check this question, when we press it on the calculator, 7 sine 30, sorry, 7 sine 30. When you check this is 3.5. That shows that this is 3.5 meter. So that shows that this opposite here is 3.5 meter. So the height and this opposite is the height. So the height that you are going to use here is 3.5 in meter. So when you now multiply everything, now have it to be 5 multiplied by 9.8 multiplied by 3.5. That is when you are going to get the potential energy, which is 171.5 joules. So that's how to calculate. Now let's go to I'm still on stage 5. Now for the stage 5, you know, when I explained the stage 4, I explained the stage 4 like when the object moves freely, like it moves downward from the plane. It moves downward from the plane. When I explain this one is when it moves downward from the plane. Now the next stage 5 I want to explain is when it is pushed upward. Let's say that an object is placed on an inclined plane like this. On an inclined plane like this. You know, we have the height, we have theta here. An object is now placed on an inclined plane. It's now pushed upward. Now if it is pushed upward, you will all believe with me that the applied force is going upward. Now when the applied force is going upward, there will be frictional force. The reason why we have there is an applied force there. It is pushed upward. Applied force push this object upward. Unlike this one that moves freely downward. This one moves freely downward. But this one, the applied force push this upward. And since it push it upward, we have the frictional force that oppose this applied force. It will, it's not as if it opposes this applied force. But because since the frictional force, the applied force push this thing upward, the motion of this object will go upward. And as the motion of this object goes upward, the frictional force will work in opposite to the motion of this object, downward. This one, for this case 4, the object move downward. So the frictional force will opposite the motion here. So since as the object is moving downward, the frictional force will opposite this towards, will opposite the motion, then it will move upward. For this case, the object, they push it upward with an applied force. So applied force is going upward. As the motion is going upward, then the frictional force will come down. Then don't forget, the normal force is with the respect to what? Don't forget we are doing stage 5 here. So the normal force is with respect to to the top. And at the same time, we are going to have the weight. And as we have weight here, you have to resolve it into 2 like this, as I did in the other time. And when you resolve it, we are going to have the side that has the theta to be what? To be cos. So this will be W cos theta. And we are going to have the other side to be what? To be sine. So this will be W what? W sine theta. I have explained this before in the previous case, whereby I explained this. I use this to explain why this side is cos and why this side is sine. When I even use this to explain. But we don't need that. Just have a shortcut that says that anywhere there is what? There is theta, we take what? Cos, and the other side we take what? We take sine. Let us now resolve this into the 2 components. The first component is summation fx, which is 0. Now when you have the summation fx to be 0, then let's go. Don't forget we have the positive x, we have the negative x. Negative x. We have the positive y here, we have the negative y here. So we are going with the x-axis first. For the x-axis, we have the summation fx to be equal to, this one is going towards the positive. So we have f plus into the bracket of both fr and w sin theta, they are working towards negative. So they will take their negative individual, in which we have minus fr. So you get me now. This one take minus, and you still have what? Minus W sine what? W sine theta. So you have it like this. Everything equals what? 0. Because both of them are working towards what? Negative. So we have negative FR and negative this. So this one that is working towards positive is going to be having what? Positive. So as we've been doing, is that you say this one is equal to this or this one is equal to this. Anyone is good. So we can say summation Fx is equal to this side, which is F. But by the time you open this bracket, it's going to be minus FR minus W sine theta. Is that you have this? Or you say this side is equal to this, which means you have F. Open this, that's minus FR. This one as well, that's minus W sine theta. Everything equals what? 0. Now let us now take these two that has minus to the other side. So we now have F to be equal to, if you take minus FR to the other side, it becomes plus FR. If you take minus W sine theta to the other side, it becomes plus W sine theta. So we can say that F is equal to FR plus W sine theta for the horizontal. Now let me go to the vertical. For the vertical summation, Fy is equal to 0. Now these are the two vertical. We only have 2 for the vertical. So that means we have summation Fy will not be, this one is going towards positive, this one is going towards negative. So we have N, then plus, this one that is going towards negative, we take minus. So that's minus W cos theta, which everything equals what? 0. So since everything equals 0, so I can say that this one is equal to this, or this one is equal to this. So I have summation Fy to be equal to N, open this, that's minus W cos theta. Or I say that this one is equal to this side, which is N minus W cos theta is equal to what? Is equal to 0. So by this time, I can see that N, if I should take this one to the other side, it will be equal to W cos what? Cos theta. So these are the things, or these are the aspects I think you need for you to understand the explanation of friction. I believe I have been able to simplify the frictional force aspect for you. If you can truly watch this, if you don't get it at first, you can watch from the beginning again. With this, you will be able to what? To get the question or to solve questions on frictional force. So with this, you'll be able to. The only exemption we have here is that, okay, there are some situations whereby they will tell you that a force is applied to push it down for this case 4. So if a force is applied on this stage to push it down, then there will be applied force here. That's the only exemption, which is the last stage, which is stage 5. So I will not be able to, which is stage 6 rather. That's the one I want to do. If peradventure there's an applied force on this case whereby they push it down, whereby they did not use the word the internal force, and in the question they will indicate the applied force that push it down. So that is the stage 6. I will not be able to complete that stage 6 here, but with those 5 cases so far, or with those 5 stages so far, I've been able to cover a lot. I am Isholade Blessing by name. My phone number is 070-6377-6455. I would love you to please just subscribe to this channel, like, reshare, repost for other people to benefit from this as well. Popularly known as General David. I am popularly known as General David. Thank you for watching. God bless you. Have a wonderful day. If you are getting this, for me to know that you are getting it, just type General David at the comment section. Let me have General David at the comment section. This is the full name of General David, or the spelling of General David. Just type this in the comment section. Thank you. God bless you.